Good morning, my name is Harris and I'll be presenting about the motion detection radar. My groupmates are Lawrence, John and Christian. They are not presenting because they're not the graduate section, but I'm in the graduate section, so I'll be presenting about this today. So overall, nothing has changed. We're still using the same system. We're using a CMD 324 radar at 24 gigahertz, which is a Doppler, operates on a Doppler radar. We built a baseband amplifier using an LM258, goes into MSP, but that changed to a MIDAC due to some circumstances, and it's still processed using a LabVIEW. Since we're still using a 9-volt battery, we decided also not to use a linear regulator due to the current consumption and when the battery gets drained, so we decided to use a DC to DC converter instead. So basically, there's nothing much. The entire power consumption for the system is 45 milliamps of current and it operates at 5.5 volts. So that's approximately 247 milliwatts for the entire system. So this is the radar working just by itself, connected to an oscilloscope. Operates on 5.5 volts. I'm not sure if you can see this, but the peak to peak is in a millivolts range. It's not a clean sinusoid, so in order to improve the signal processing and improve the output of the radar, we use a baseband amplifier to improve all of that. So basically what we did was we implemented a inverting amplifier. So this is the simulated schematic. So I'm using a 10K and it says it's a 1K here, but I changed that to a 10 ohm resistor to give us a better gain. So that gives us approximately about 100 gain when I tested it. But however, due to my rails, just because my rails is set from 0 to 5.5, anything above even 6, 7 or 8 is not gonna get cut off due to my rails. So in the end, for testing purposes, I did use a 1K because then it gives me approximately 10 times gain, and John said that would be sufficient for when he does the signal processing aspect of it. So this is when I built, this is when the circuit's built. So this is the baseband amplifier. When you put in the signal, now you can see it's now at approximately at a volt instead of a millivolts range. It's at 1.86 volts. Frequency is still about 2.3 kilohertz. That's what we're expecting. So that's about the right frequency. So as you can see, that's about a 10 times gain because initially it was in a millivolts range. Now it's in a volts range, and then it's an inverting op amp too. So we know this signal was strong enough and sufficient to put in the MIDAC in overall. So basically, this is what my other groupmates focused on. It was not my focus. We used the MIDAC to handle all of the signal processing aspect of it. They process the signal in here and everything goes in. But this is using, they used a Visa Open, and I think they had a problem with this, and they used, instead of using, so initially we started using a microcontroller, the MSP 430, but after that, we found out there was just a lot of problems with it and stuff, so we just moved on to a MIDAC instead. So this was the signal coming out on the output for the MIDAC. So as you can see, we're getting like clean signals and stuff, so that's fine, that everything works good. So this was the complications. It wasn't giving us the right output and stuff, but no, wait. So okay, this was the complicated part. It wasn't giving us, it was theoretically working, but then when we plugged it into the radar, it wasn't giving us the right values and stuff. So we fixed it using this, and this is the MIDAC. This is for the MIDAC. So this is how, so the final system setup, instead of using a breadboard for the entire system, like in here, what I did was I moved everything on a breadboard to a soldered breadboard. So this is so I used a DC to DC converter, which is a buck converter, to make sure the battery stays, battery consumption stays constant. Because once you put in 9 volts, you need to be stepped down to approximately 5.5. We chose a 9-volt battery because that was the easiest, and the entire system runs off 5.5 volts. So we use a buck converter to make sure that 5.5 volts is always constant and it doesn't drop as the battery drains. Everything is on the soldered breadboard. We have the radar right here. And we have the baseband amplifier somewhere there. So that's how everything was set up. Everything was put in exactly like that when we presented to Ashish. So as you can see, at 4 Hz, we're getting very good it was a decent amount of signal. And then at 5 Hz, we processed it at 7 and 9, and that's when it got a lot better. So this worked with the MIDAC, and it worked a lot better, so we just stayed with the MIDAC in the end. So this is the video of the thing working. Unfortunately, the video is not working, but I'll send the video to Dr. Lee personally, and if you all have any questions, feel free to contact me. Thank you. So everything's off my bad, the Gantt chart, everything, on demo day, everything worked fine. We got the values we needed and stuff, and all of that. So everything got done on time, but that's it. So